Hi there! Today we're going to talk more about regrouping. I know we've been talking about it a lot. You guys have figured out how to draw a picture to show what's happening when we're regrouping. You've learned how to figure out how to look at a problem and decide if regrouping needs to happen or not, which is a very smart thing to do before you get started in a problem. Now we're going to learn how to connect, learn about, understand how that proof picture we've been doing can be done with just the problem numbers, okay? Don't forget, I always want you to draw a proof picture, okay? Sometimes I'll ask, it might be better for your brain to do it first, then do this next step I'm going to show you, or your brain might like it better to do this step first, then do a picture to prove it, okay? Either way, it's fine with me as long as you do both things, okay? For moms and dads who might be watching this video, guess what? This is the traditional algorithm, that's the fancy math word, for what you and I learned for subtraction with regrouping when we were in school, okay? So here it is. We haven't abandoned that. In fact, Common Core Math really doesn't abandon those things. It teaches the deeper learning concepts in other ways first. It teaches multiple strategies so kids who learn in different ways can see different ways of doing a problem so that their understanding can be beyond just crossing out the tens and changing it to a smaller number and then adding a 10 to the other one. That's how we learned. I didn't understand why I was doing that. The whole point of this curriculum and this Common Core push is that kids understand what's really happening. We're still going to teach them the traditional algorithm, and that's what I'm going to do today. But the difference is that I didn't teach it first. I didn't teach rules that just were meaningless. I taught them meaning first, and now I'm teaching them to connect that meaning to the rules. Okay? You're going to see what I mean in just a second. All right, so we've got two double-digit numbers we're going to need to do regrouping. So we've got, let's take 87, and we're going to subtract 49. Okay? Now, the first thing we've been trying to do is to look at the problem by tens and ones, right, to decide whether we will need to regroup or not. Okay? I'm going to grab a white piece of paper so I can look at it one side at a time. This piece of paper really helps me remember that I'm not looking at my problem left to right anymore. I'm looking at it horizontal and vertical. So I'm going to cover up the ones, look at the tens. They look good. I should be able to take 4 tens from 8 tens. Yep, that'll work. Then I'm going to cover up the one side. And this is the one that really makes the decision, the one that decides whether we're going to need to regroup or not. Okay? So we've got 7 ones on top and 9 ones on the bottom. If you have 7 pieces of gum, can I come and take 9 from you? No, because you don't have enough. You don't have 9 for me to take from you. So we're going to have to get more ones. And the way to do that is to take some ones away from our 10. And since this side over here is tens, when we take ones away to get more ones, or on this side, we're going to take a whole 10, okay? That way this side can stay tens, okay? So we've done this in a picture. Let's do the proof picture first. I think for students who struggle with some of the math understanding, the picture first is the best, a lot of times the best way for their brain, okay? They see it, it's visual, it makes sense, then we connect to the traditional algorithm, okay? Now, students who there are struggling learners who do better with the algorithm and then going to the picture to check it. Just depends on the kid, okay? We're going to do the picture first. So we've got 87, 10, 20, 30, 40, 50, 60, 70, 80, 81, 82, 83, 84, 85, 86, 87. We're going to take away 49. So if I'm going to take off 49, I need to show myself doing that. Take off 10, 20, 30, 40, 41, 42, 43, 44, 41, 42, 43, 44, 45, 46, 47. Uh-oh, I'm out. So I've got to get some more. So I'm going to take this 10 and I'm going to break it. And this is how I'm going to show myself doing that. I'm going to make it longer and show the tens inside of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So important that when you do this on your paper, that you make sure those dots are nice and big so you can count them, and that they're spaced out so you can make sure that you've got the right number. So I had 47 I had taken away. I need more to get to 49. 47, 48, 49. Now I can count what's left, okay? I'm going to start by counting my whole tens first. Taken 10, that 10's not here anymore because he's got a line through it. We took him. Taken, broken, whole. There's a whole 10. That's where I'm going to start counting. 10, 20, 30, freeze. These are all taken, can't count them. 31, 32, 33, 34, 35, 36, 37, 38. So in my proof picture, my other missing part would be 38, because if I made a math mountain, I know 87 is my whole, my big guy total, 49 is part of my 87, and what the answer that I'm trying to find is the missing part, right here. Okay, so now let's look at the traditional algorithm. Okay, what we did over here was we realized there were not enough ones on top to take 9 from, so we need more ones. So to get those ones, we took a 10 and we moved it, we broke them into ones, okay? So I'm going to take a 10 and I'm going to move this 10 over here. So 7 plus 10. So if I put 10 more here, I'm adding 10 to this 7. 10 plus 7 is 17, okay? Now, since I took one 10 away from here, then I don't have 8 10s anymore. I have one less. So instead of 8 10s, now I have 7 10s. So it's looking like more something Mom and Dad have done when they were growing up. Okay? Now I can do the ones column first. 17, take away 9. Okay? I know how to do those problems. I can grab the little guy and count up, or I can grab the big guy and count down. Lots of times for a struggling learner, it's easier to count up than down. So I'm going to grab the 9, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay? Now I'm done with the ones. Now I'm going over to the 10 side. Now I've got 7 10s, take away 4 10s. That's pretty easy. I know that 4 goes with 3 to make 7, so the missing part is 3 10s, okay? There's my missing part, 38, matches my proof picture, matches my math mountain, okay? So we connected our understanding of what was happening to the 10s and the 1s and put that understanding into a traditional problem. So I could see that I took a 10 and I gave it over here. I put it over there. And when I moved it over there, I had to add it to the ones that were already in the one spot. There were already 7, and I added a 10. 10 plus 7 is 17. That's something we can do in our head, because we know that when you're adding a 10, you're only got 1 10 and 0 1s. If I add 7 1s over, it turns into 17. Okay?